invite you and to be here at this ntop mini conference that this year we have to organize, unfortunately, over the internet. The idea is to be here today and to discuss about what we have done this year, to discuss future work items, and then to decide together where to go. The schedule is pretty simple. We want to be in touch with everyone. We want to talk about the idea of having a community here today, the ntop community. And even though we would have liked to meet you in person, the original idea was to have a conference scheduled last May in Milan. We have to be here remotely and to enjoy the fact that it is possible to at least meet virtually. As I've said today, it's a pleasure for us to have you here, and we have decided to divide this sort of conference into 3 different sessions. This to make it short in time, because people don't usually like to stay long online. And for this reason, we have decided to divide in 3 parts. The first part today is an overview of what we have done. In essence, what happened this year, the new releases. So just to give you an overview of what ntop has developed and to discuss together the roadmap. The second event is December the 3rd. We'll focus on ntopng. In particular, we'll be talking about the 4.2 release, the NEdge, that is the inline version of ntopng that is able to inspect the traffic and to enforce policies. We'll have another presentation of ntop used in pharmacy, and we are also having a new product roadmap, and we also have some presentation about ntop embedded on Kubernetes devices. On December 10th, we'll be talking about Mprobe and the newest end-to-disk version. And so we'll be talking about packet to disk and high-speed packet capture and processing. The program of the day is the following. First of all, I want to give you an introduction and an overview of the roadmap. I want to introduce Mprobe and Mprobe Cento as an Ndpi. Then I will leave Simone, the duty of talking about ntopng 4.2, and then Matteo discussing the alerting subsystem in ntopng, and then Martin Scheu from Switch will be talking about ICS and SCADA monitoring. That is an interesting new topic that he has, introduced, and he's educating us to it. And then we have Francesco, that has worked a lot in end-to-end. It's a peer-to-peer VPN that I have started to develop many years ago that is now being maintained by the community. And then finally, Alfredo will talk about PF-Ring 7.8 and to disk and scrub as update. And then at the end, we'll have a public discussion. So the idea today is to have some very short presentations, and then at the end to discuss, for those who want to stay, the roadmap items. So first of all, let me say that ntop is mainly a community. A community means that it's a place where people can meet. We are mostly based on open source software development. So we believe that in terms of software, but also in terms of community. So if you go to the link ntop.org/community, you will see that we have 2 ways of talking with the community and talking with the team. So the first one on the left is called Discord. It is interesting. I don't know if everybody is familiar with it. It is interesting because it is possible to exchange messages, to talk, okay, similar to what we are doing today, and to share screen. This is great for support, for talking with people. And the one on the right side is Telegram. That is more chat-based, and it's useful because many people have it installed on the mobile, so you can interact with us even in this way. We prefer Discord, in particular if you want to have support, because Discord is divided in subtopics, whereas Telegram is all mixed. So sometimes you have to follow discussion here because one message interleaved with the other. I suggest for those who have not joined yet to go there and to contact us and to share ideas, because we are constantly looking for new ideas and new interesting topic to cover. Let me give you a short overview of what we have done this year. First of all, we have worked almost 1 year to the ntopng for releasing. This is something we have introduced the past spring. It is interesting because it's a major rework. Actually, the 4.2 release, that is something we have just introduced that Simone will describe later, is just an evolution of the 4.0, where we have decided to address many of the concerns and the issues that people have reported us. In essence, it's a consolidation and extension of some features, mostly for cybersecurity, that we have prototyped over the months and that we have implemented in Ndpi. Ndpi, I will show you later, is the packet inspection library written by ntop and open source. It is good that many people from the ntop community are contributing to it. It is not just something that we maintain, but it's something that people are contributing to, and this is very important. We have decided to spend a lot of time in encryption, traffic analysis, because ETA is something that is very important, in particular these days where most of the traffic is encrypted. And also, we wanted to add in the library the basic mechanism for traffic behavior analysis. And this is important because we can have in one place, open source, no secret, all the algorithms that other applications, that not just those from ntop, can use. We have also decided to open a little bit us to third parties. So, for instance, we have had the integration with Suricata. Suricata is a popular open source IDS, so that we can complement the features that we already have with Suricata alerting. And recently, we have announced that you can go to blog.ntop.org if you want to see details, or you will hear this in the second part of the event on December the 3rd. Security Onion, that is a popular open source Linux distribution for cybersecurity. And because many people ask us to also add support for third-party vendors, so we have added inside ntopng the ability of receiving events from those devices and for using them inside ntopng. This because it is very important, and at least this is our view, not to be bound just to packets or to a few standards such as NetFlow, SFlow, or IPFix, but also to be able to support the popular devices that are able to export monitoring information in, let's say, non-standard ways, so that we can increase what we have already done. We have also done quite some work in embedding ntopng and embedding our tools. So you will hear about checknk in a future event. That is a popular tool developed by Tribe29. It's a German company that has been integrated with ntopng. Or Kubro, that is an Austrian manufacturer of tap devices that is using our tools inside its embedded devices for high-speed tap or traffic analysis. Cpacket is a manufacturer, an American manufacturer of high-end devices that is using our Mprobe as as cornerstone, as engine for one of their products. You will hear about that. And finally, Nokia, that is a very well-known manufacturer. So we have integrated inside the Nokia product our Improbe, just to demonstrate that visibility is not something that requires a PC, but it's also something that you can do at home inside your meshed Wi-Fi device. If I have to look also at what we have done for traffic analysis, so we have supported the latest Intel cards. So Alfredo will talk about that, and of course, also the latest extensions available for FPGA-based adapters. And in particular, it is also possible to support via XDP those devices that are not directly supported by PFRing ZC. In addition to that, we have also extended the support for DDoS mitigation and traffic cleanup in Nscrub. That is our infrastructure for monitoring and for making sure that the network infrastructure, is in good health. In particular, is working well under attack. And like I've said before, thanks to Martin, we have started to do some initial step in ICS SCADA, and soon in IoT, thanks to a European project where we'll be active. The second thing I want to say, this is a quick overview, is I want to talk today is the new roadmap. So in essence, the idea that we have in mind today is to share with you what we'll be doing next. And we believe that what we have done is very important, but what we'll be doing is probably more important. That's why your feedback is compulsory for us, because sometimes we decide in meetings to implement this or that, but you are the user community, and being you the user, you are those who are able to understand the real needs, and sometimes that we are not able to imagine. So it's very important for you to listen to this, and like I've said, at the end of this session we'll have a discussion. We want to keep the presentation short so that you can see bits and pieces of everything. Now let's talk about the roadmap. So in essence, what are the key motivations for us for extending our tools in 2021? Okay, first of all, we have realized that the network monitoring, as it has been perceived for years, is changing. We see that with the advent of the cloud, with the fact that many people don't use a PC anymore, or with the fact that not everybody is very well educated to have a tap or to configure a mirror port on a switch, is becoming more and more important, not to focus on standard, but to focus on the fact that network admins are changing. And therefore, we should follow more or less the trend here. So if a network admin in the past we used to bash, let's say, today network admins are used to JSON, are used to this type of high-end tools, Grafana, this type of popular tools that they are already using for other activities. And another trend that we have to follow is the encryption. So it's very important to preserve, privacy, and it's very important also to make sure that the data that we are monitoring is safe. And popular protocols such as NetFlow and NetFlow are unencrypted because they were designed many years ago to do something totally different, in essence, to do network monitoring in a LAN. Today, with the advent of the cloud, with the fact that sometimes the data is not stored in the same location where it is produced, and sometimes the location is abroad, it is very important to transfer this information in a safe way. But also on LAN, it's important that every communication is encrypted. So therefore, we have realized that because of these trends, people tend to have monitoring probes in one place and the engine that analyzes all this information in another place. It is also something that we have realized, the fact that people like to look at packets, like IP addresses and so on, but mostly they don't have time because the infrastructure is growing, and they want to have somehow a summary of what is happening in terms of alerts. So in essence, instead of having very small and raw events, they like to have something like, ideally red, yellow, or green dashboards that more or less describes what is working well and what is not working well. Drill down is important, but too much information is confusing the user. They simply want to have an infrastructure that is running, is in good health. And eventually, in case of trouble, or in case they believe it's important, they want to drill down. But the fact that, for instance, everybody is an expert of understanding, how networks are working is not a true statement. So in essence, we want to move from raw signals, so for instance, from packets or to flows, to facts, to say, okay, this is what is happening, not just give people too much low information. And we believe that, in a way, computer science is now a commodity. You can go in every shop and see that you can buy for $100, €100, a multi-core phone with, machine learning ability. So we are wondering, why is network monitoring still so special? So why there are people that need to pay a lot of money for monitoring their network, and why some of those tools are complicated. So we think that SMEs are an important from our point of view, environment where we could apply our ideas, because in these people, in this environment, sorry, we have people relying on networks, but not often these people are experts of networking. So we should be able to somehow present them the data in a way that is clear, it's easy to understand. So for us, it's very important to invest on the packet inspection, to know more about the traffic that is flowing in the network, and also to give people information about cybersecurity, because this is a big concern, at least from what we have heard while chatting with people. This is the problem number one today, because people are very much concerned about people entering into their network and breaking up security. This is not what they like. And also we have realized that, IDSs and IPSs are devices for experts. So sometimes vendor come, install the device and configure it. But most of the time, people are afraid of touching them simply because they're complicated, and the alerts they're producing are very low end, and they are not simple to understand. Another fact that is pushed us towards this draft roadmap I'm talking today is the fact there are many devices, most of them Linux-based, available in our home or a small network. That they're extensible, because it is possible to install application on them. So it's no longer necessary, like I've said in the previous slide, to add new components, to unwire, to do things that are part of the past, or that are part of enterprises, big enterprises. So in essence, we would like to fill the gap of monitoring and visibility into places where people are not expert of the field, but they need to make sure that everything is working, everything is good shape. And the story that I want to tell you today has to start from the current state of the art. So in essence, what we have today on the table. So if we look at our tools, we have in essence 3 types of tools. The high end is nscrub, that it's an application able to mitigate DDoS attack. So we're talking about 10 gigabit plus, and to keep the infrastructure in good health. So good tool, but for very few people. In the middle, we have ntopng Edge, that is the inline edition of ntopng. So imagine ntopng with the ability of blocking traffic. That is a good tool, but is able to operate up to 5 gigabit. So the high-end people will be disappointed by that. The low-end people will say, okay, this is too complicated. And for 3 years now, we have created a product called NFW. That is something we use internally that we are never released, for understanding what are the needs of small businesses, of families, of those who need to protect themselves. So to block, basic security threats, and that will have a super high speed. So something that will not exceed 1 gigabit. So this is what we currently have on the table today. So the question is, how we want to see the future? How do we want to imagine what we'll be doing next year? Starting from what we already have. So from probes, from ntopng, from this type of applications. So in essence, our vision is to combine visibility with enforcement. This means that we want to see what is happening on a network, but at the same time, we want to make sure that the traffic that is flowing in a network is good. So in essence, that the policies that people believe they have put in place are satisfied, and if there is something wrong, to block them. You might say, okay, this is something that a security device should do. This is true, but unfortunately, most security devices are not so easy to configure, and they are not so flexible to configure. So just to give you an idea, it's almost impossible to tell to a device that can run at work in a small office to say allow people to do certain things during certain hour, but not for longer than, or example of protection of people coming with a cellular phone at home and entering your network just for a specific purpose. So the idea that we have in mind is somehow to think about multiple scenarios. The first one is to produce monitoring data. So something like Mprobe is able to do, in essence, to see what is happening and to export this information to some consumers. That can be other ntop tools such as ntopng, or external tools, external consumers. To have at the same time the ability for those who need that, not everybody, but for those who need that, to enforce at various speeds. So in essence, to have a solution for ranging from multi 10 gigabit to low, less than 1 gigabit connections that allows to protect small businesses, homes, and enterprises. So in essence, we want to provide not just DDoS protection, because this is not something, it's a problem that affects everybody, but to protect people from security threats. So for instance, provide basic security that does not require configuration. So we don't expect people to be able to configure, complex IDSs, but we want to have, some sort of visibility plus protection, where protection is something that will be optional, and that is already implemented bits and pieces in many of our tools. And at the same time, we want to extend ntopng to provide better analysis of the data and to create better alerts. And the alerts have to be very precise. So whenever we see something bad happening, I want to know who is the attacker, who is the victim. Unfortunately, most of the tools we have found, especially those open source, are just reporting a lot of information, but they don't have this data. So you have to guess, because sometimes in one alert, the client is the victim. In another alert, the client is the attacker. This is very important, because if we want to stop people, so if you want to set a rule in the firewall or in, let's say, tools like fail to ban, block this guy because this guy is doing something bad to the network, is something we are willing to do, and we are willing to implement this year. We must make sure that the information we rely on is accurate, it is stable, because we are blocking people, we are blocking traffic. So protection is good if it works. So we believe that enforcement is an optional step. It's not for everybody. Many people don't like to put protection in line, okay, because this is probably something that they don't want to do. But doing also protection offline, such as via SNMP, via BGP, or via other tools, it's important for mitigating cyber attacks. So this is one of the things that we have in mind. So in essence, just to summarize this with a picture, we want to have on one place, devices, either devices that you already have at home enhanced with one of our agents, or new devices, or small devices like the one at the bottom, or existing firewalls such as Mprobe Cento. That is something that we believe it's important to look at, that can be enriched with our tools, so that we provide visibility. So you can install those probes into, or sensors, if you wish, on those existing devices or existing firewalls, and send to ntopng that can run on premise or on the cloud. Like I've said before, we have encrypted everything, so it is safe to move data in a different data center on the cloud. So this is really up to you. And at the same time, ntopng can do some enforcement by, again, optional. If people believe that this has value, and people believe that this is possible to do in this environment. So for instance, in industrial environment, this might not be a good idea to implement this type of enforcement. Note that ntopng has been designed, at least from version 4, as a multi-tenant application. So it means that you can install ntopng once, and multiple people can connect to it, and everybody cannot see what others are doing. So in essence, ntopng is able to shield, to limit the visibility of traffic to the information that is necessary and is relevant for a given user, and not to violate the privacy, simply showing information that should not be exposed to other people. So in essence, we want to go towards something that we call ntop as a service. That doesn't mean that we'll be offering, ntop services. Maybe yes, maybe no. We don't know. We don't have plans yet for that. But for sure, we want to enable our customers, our user community, even those that are using the open source version, to do that, because we see that many people, many consultants are relying on our tools, and they put and embed those tools into small boxes that they deliver to users. And we would like to, first of all, to make it simpler to them, so that they can take a simple low-end box they can buy on Amazon, install ntopng, and from ntopng to be able to configure everything, because today you see that our tools are a little bit fragmented. So we have Mprobe on one side, ntopng on the other side, N2Disk. So everything seems to be complicated. Whereas the idea here is to configure the system in a way that everything is possible from ntopng itself, so that you can configure the network, you can configure the firewall policy, and you can configure the companion applications such as Mprobe. Everything has to be simple. So this will empower some of our users to make money, to rely on us, and hopefully to support us with the development. This is very important for us. So at the moment that we want to enable you to do that. Later on, this is a good argument to discuss today to understand whether, ntop as a service makes sense to you. This picture is something that Martin has created some time ago that very much liked and adopted. And we believe that the goal for 2021 is to go to the anticipate. So for years, we have talked about security, about defending our assets, monitoring or managing networks. Now we want to go to the anticipate box. Anticipate means that we are not just looking at what is happening, but we want to predict what it will be happening according to the trend that we see, we observe on our network. So this is very important. So this is the place where we want to be, likely in 1 year, maybe in 2, but this is where we want to go. We are not happy of putting information on a dashboard. We want to interpret this information, and we want to make simple for people to rely on this information and to create complex applications. So this is our main goal: anticipate. And if I look at what is happening, at least in our community, listening to people that are contacting us, one perception of us is that we have always produced sensors, so probes or tools that produce data. But over the years, this is no longer sufficient, because we believe that people should also understand that we are able to do more than that. We are able to consolidate data. When I started ntop, the original project, more than 20 years ago, my idea was to simplify visibility of a network through a web interface, presenting data in a way that was simple for people to understand, such as a spreadsheet where you can click on columns, sort data, and to do things that you normally do with, let's say, Excel. Now, we want to do the same, but we want to consolidate the raw information that is coming from the network in a way so that not just expert, but everybody can understand what is happening in a network and whether this is good or bad. For us, encrypted traffic analysis, like I've said, is very important, because encryption is the way to go, is the future, actually is also the present. And we want to provide people more visibility on unknown traffic, to give them an idea of what is happening and what is not working in this traffic. So like you will see in a few minutes, we have added the ability in ntopng, for instance, of detecting beaconing. And this is a good start for detecting malware activities that are often relying on this type of techniques. And this means that we have to identify services. We have to understand how the traffic is flowing in our network. And once we have something that we call a service map, it is possible also to easily understand and recognize some of the malwares that are a bit more complicated to recognize using techniques that don't rely on this type of information. Like I said, for physical network, for industrial network and IoT, we plan to do some work, in particular with a Greek partner. We have been involved in a European project that will bring us into this new field. And for us, it is very important to make sure that, especially for small businesses or for those places where IoT is becoming important, where there is not a lot of traffic, but the traffic is very important because these IoT devices are controlling important things like a gate, a door, a light, temperature. Everything is protected. So this is what we want to learn from people that are already in this field for a long time. You will hear later from Switch about SCADA. And next year, we want to really put new features that are able for people used to IoT to protect their network. And of course, talking about other minor goals. First of all, we want to continue with the integration. OPNsense is the first thing that we want to do. We have to rethink a little bit how time series are implemented in our tools, because for years we have relied on RRD and InfluxDB. But we see some limitations in terms of scalability, in particular on networks that have a lot of data. So we have to think how to overcome this limitation. That is not an ntop limitation, but it's a limitation of the tools that we are using. Some people are asking us, do you do machine learning? No, we don't do machine learning. Maybe we'll do machine learning, but at the moment it is not an argument, because we believe that first of all, there is a lot to be done using statistical methods that are much simpler, much lighter. And then eventually, next year or in the coming years, we'll be thinking again about machine learning. But using machine learning for doing things that are simple to do with statistical method doesn't make any sense, because we want to make we want to develop tools that are simple and that can run on a Raspberry. We don't want to create a huge software that are able to run only on computer with a lot of memory. This is not our goal. We want to stay close to what we have done for 20 years, and we want to continue creating software that is effective. Finally, for traffic processing, you know that we have a tradition due to PF-Ring of being active in this field. So if I look at what we have done in the past few years, in 2016, we have started to integrate into our tools FPGA-based flow processing that is supported by Accolades cards. This is still present with enhancement this year. But in addition to that, we wanted to explore other possibilities. In 2019, it's no secret that we have developed the PDK driver for Pensando's P4-based products, and we believe that these are interesting products where we can probably offload some of the functionalities that we are implementing in software in hardware. And this year we have done, we have created a small IDS IPS based on Napatech's FPGA flow management facilities present in the latest cards. This has been a good experiment for us because we have learned how to offload to the card some of the functionalities, in particular flow management, that we implement in software. What we want to do in 2021 is more or less to consolidate what we have done, to rethink a little bit PF-Ring FT. That is an extension of PF-Ring that allows to deal with flows, and to see what we have to do in order to put into this library the ability of supporting hardware for offloading to hardware, the flow management. That in essence is the main problem that many people have, from security to monitoring. Everybody has the same problem because all those tools are based on the same concept. So we want to really see, if the market is now ready for this type of solution, for new solutions based on that. This is more or less where we want to bring PF-Ring. So just to summarize this presentation, I don't want to be too long. We want to do this in essence in 2021. At least this is the plan we want to discuss later. First of all, to focus more and more on cybersecurity. This is what people want. We don't want to move data, but we want to move alerts. We want to move signals that are easy to understand for everybody. In addition to visibility, we want to do enforcement, more or less like we have started to do, but in a more comprehensive way, reordering, our tools. And this means that we have to reorganize more or less the tools. Sometimes people have a hard time to understand the differences. This is our fault, so we need to do that, and we need to simplify more or less the tools that people have to use in different use cases. Like I've said, we want to enhance ntopng based solutions, not just for monitoring, but also for enforcing the traffic, relying on other ntop components. And we want this to be effective for families, small businesses, and enterprises. We don't want to focus only one of them, but we want our tools to be able to be available to everybody. And also, the hardware has a lot of innovations, and we believe that it's important to exploit them, in particular for processing traffic based on the packet inspection, because for years we have relied on IP addresses and ports, and this is no longer enough for many people. We believe that DPI is important, and this is what we are supposed to do. Now I will give you a quick update on Ndpi and Mprobe. And then later I'll pass this to my colleague just to continue with this update. What is Ndpi? Ndpi is an open source deep packet inspection toolkit that ntop has developed and is developing since 8 years. So in essence, we are able to guess the application protocol, or to understand what is the real application protocol, look at the packet payload, so look at the data that is flowing. And a typical example is our tool Mprobe or ntopng that is monitoring the traffic. So in essence, we capture the packet, we pass it to Ndpi. Ndpi characterizes the traffic, produces metadata, and report this to the application. We have decided to make Ndpi open source. So this year we have invested some money also to create it a trademark so that people can perceive it as free, and that is free and it will be free. So they're free to integrate it in our tools, in their tools. So we see more and more Ndpi integrated in commercial products or in open source, like most routers based on Linux now have Ndpi, have kernel modules based on Ndpi. Ndpi in the past year is something that we have really developed a lot, because we have wanted to have the latest algorithm for detecting, let's say, threats, or also for understanding, encrypted traffic. So the main two things that we have implemented in Ndpi 3.4 that has been just released is extensive support of TLS and QUIC. So these are the two main protocols that will be more and more popular over the couple, I believe, a couple of years. Basically, everybody will use that. They are the new TCP in essence. Everything has to be encrypted. Already today, most of the traffic on the internet is encrypted, but it will be more and more even on a LAN. So we wanted to be able to understand and interpret this traffic. We have done a webinar about that. Probably we'll do another webinar in the future to those who are interested in this type of topics. And the encrypted traffic analysis, we wanted it to be, one of the main features of Ndpi. So we are able to monitor this traffic in the same way as other popular IDSs are doing, with very low CPU usage. This is very important because we monitor just the first few packets that for us are enough to extract the metadata that is relevant for application. In addition to understanding the content based on the initial packets of TLS or QUIC, we have also created some algorithms that are able to understand the behavior. So for instance, to compute the entropy and to see whether we are transferring the information we expect. And also to cluster data so that we can put together some flows that are somehow similar, and everything is done by Ndpi, so without adding external tools. Another good addition, in essence, is the ability in Ndpi to introduce new algorithms that are able to cluster data or to, based on the data binding, to compare data, to put data one next to the other. And these using statistical methods. So are pretty simple. The memory is very much reduced. Seems to work reliably even on very small machines. And this is confirmed by the fact that, for instance, ntopng is using them, and ntopng is able to run on a Raspberry. So we have introduced all the algorithm for cardinality estimation, or that is the typical algorithm you need for creating the top X that have done something, or for monitoring data. For those who are using Python, the Python bindings have been greatly extended as well. Ndpi includes serialization techniques based on JSON or on a proprietary binary format that is very efficient, yet open source. And the main thing is that everything is fully tested thanks to fuzzy testing. This because Ndpi, like I've shown in a previous picture, is at the bottom of the stack. So in essence, we capture packet, we do the packet inspection, and everything on top of it. And it is very important that everything is fully tested. There are no leaks and no crashes because we fail. And just to conclude, in Ndpi 3.4, we have added something called Fluoresce. So in essence, the library itself is able to understand many problems. This is just a list that are included in the traffic, and this is very important for securing, in a simple and effective way, at least providing a baseline security for many people, because, for instance, we can block usage of suspicious protocols or transfer of binary applications that are usually the way malware are penetrating into their network. So this is Ndpi 3.4. I want to also give you a quick update on Mprobe and Mprobe Cento. Mprobe is an extensible software probe that in essence is able to capture packet and to turn them into flows, or to collect flows that are created by a router and to do two things: either to be a proxy, so that it can convert the flow from one format to another and export them, so this is called proxy mode, or to collect flows and send them as JSON or as a text to external consumers such as Kafka, Elasticsearch, syslog, or to do streaming. This year we have put a lot of energy exploiting Ndpi in Mprobe, so that we can exploit it not just to detect the protocol itself, but also to export metadata. And this is very important, in particular for protocols that are rich or that are hard because they are closed to decode, such as, for instance, WhatsApp, just to give you an idea. So Mprobe is able to monitor this traffic and to report information about those protocols. So what's new in 9.2? We have seen that over the years we have put a lot of energy in probing, in the probe side of Mprobe. Now we want to extend also the collector side, because many people have devices that are able to create flows. So we wanted to make this possible at high speed. So in essence, just to make this long story short, we have introduced a new facility called collector passthrough, that is able to collect flows in Mprobe and send them in the same format as they are, so no transformation, at a very high speed. So in essence, this is something that allows us to move from 25,000 flows per second to more than 100,000 flows per second per core. So it means that if you have a multi-core machine, you can start multiple Mprobes on the same machine. This is very important because we see that people are moving to JSON. So people don't care a lot about standard formats such as IPFix. This was more relevant in the past, so it's relevant just for a few people. So this is a good way of capturing flows and sending them in a streamed way to remote consumers. This is the first thing we have done. The second is the ability to support many routers. In a typical Mprobe, it's possible to support more than 128 probes. And this is very important, in particular for companies that have a lot of routers, a lot of edge devices that are not probably sending a lot of data, but there are many. So they have a large number, a large cardinality. So this is very important. Like I've said, we have extended the Mprobe with the latest Ndpi extension that allows us to understand, the risk on a given flow, or to understand whether the protocol is following our expectation in terms of entropy, inter-arrival time, and so on. For those who are acting in mobile network, we have added VoLTE support and enhanced GTP support. And for those who care about running Mprobe in small environments, we have enhanced the OpenWRT support. Like we said before, or if you want to read the ntop log, it's possible to run Mprobe inside the small devices such as the Nokia Beacon to provide visibility also in places where Mprobe was not designed for that. Mprobe Cento is the high-end version of Mprobe. In order to make it fast, we had to somehow to remove, some flexibility. So the flow format in Cento is static. It is not designed for collecting flows, but only for collecting packets and generating flows. So what is special about Cento? From the Latin word, Cento means 100. So Cento is able to do 100 gigabit in essence. So it is the high-speed version of Mprobe, and is one software that is no longer doing just packet to NetFlow packet to IPFix, but also more than that. So you can see two use cases here. So for instance, it has the ability of creating flows and at the same time balancing traffic to multiple consumer applications such as DSS, or to allow also to create a policer so that it can operate in line, so that you can create flow records and at the same time block traffic that is not compliant with the policy. What's new about Cento 1.12? That is the latest version. So we have added all the features that Ndpi offers in terms of analysis and analysis of encrypted protocols. We have extended the 0MQ so that the 0MQ is the protocol that allows external tools such as Mprobe or Mprobe Cento to speak with ntopng. So in essence, this means that ntopng is able to operate at high speed relying on flows generated by Cento. This through basically two things. First of all, batching, so that we can pack multiple flows into a single batch to avoid, network traffic when possible, or to do load balancing. So in case this is very likely at 40 or even more at 100, Cento produces a lot of flows that can be balanced across multiple virtual interfaces of ntopng. We have implemented, like I said before, flow offload support thanks to FPGA-based hardware vendors. So this means that we are able to operate at higher speed using low-end servers, because in essence, most of the work after the first few packets is done by hardware, by the network adapter. Instead, we still rely on the CPU for processing continuously packet. And like I said, we have addressed the various performance bottlenecks in Cento so that the performance is better and the CPU is slower. And at the end, we have added support for the latest CentOS Red Hat and the latest Ubuntu. This is all for today. Before letting my colleagues speak, I thought that it was a good idea that we can provide for those who don't use the open source version of our tools, to provide a discount code that you can use till the end of this week, so a sort of Black Friday discount. For those who want to use our tools and that want to save a little bit of money this week, can use this 2020 discount. Like I said before, I would like to continue with the presentation. Then at the end, we'll do a session where we have an open discussion, and that where everybody can talk and ask a question or comment on this roadmap. Thank you, everybody. Simone, I think it's time for you to present. I don't know if you can take over.
Thank you, Luca, for this introduction, and thanks everyone for joining us today. Let me see if I can share my screen right now. Okay. Yeah. Okay, can you see the presentation?
Yes, Simone.
Okay, thank you, Luca, again. And yes, today I'm gonna briefly show you the main new features of these latest ntopng 4.2. So yes, you're going to start with a brief introduction and motivation, and then just look at the main new features of ntopng. Among the main new features, as Luca have already said, we are going to see the encrypted and periodic analysis of traffic, or how to proactively respond to network anomalies. So again, as also Luca has explained before during the introduction, we are going to see how to use ntopng to actually mitigate certain suspicious behaviors seen in the traffic. We'll also briefly see the IoT and SCADA part, as well as the way to handle alerts in a flexible way, I would say. So yes, this 4.2 release of ntopng is basically an effort, our continuous effort to keep focusing more and more on the security aspects of the traffic analysis. That is, traditional monitoring is fine. We do believe that traditional monitoring is useful to understand application performance, quality of service, the way that users experience the network, and that's completely fine, but it's necessary today to add to this traditional monitoring all a series of security-based network measurements, or a series of security-based network monitoring, I would say. So among these new challenges, among the challenges that we are facing, I would like to mention the analysis of encrypted traffic, which does not mean to decrypt the traffic, but it means to understand the behavior of the encrypted traffic, to partially analyze the clear text information that travels along with the encrypted traffic to detect certain kind of information and behaviors that will help us in telling you this is a good traffic, this is a bad traffic. Also, it's among the new challenges, we have worked on the detection of vulnerable protocol and which ciphers used to encrypt the traffic. We also focused on the visibility of IoT devices because, you know, IoT devices are more and more popular in any corporate infrastructure, I would say, but also at home, because it's now really, IoT devices are popular. Just think about security cameras, badge readers, or temperature sensors, or whatever. I mean, these IoT devices are spread in the network infrastructures, and typically they also tend to be vulnerable because they are cheap devices that are seldomly updated. So it's important to monitor their behavior and to understand if they are behaving correctly or not. Then among the new challenges, we would like to be able to timely identify and somehow anticipate a certain bad event to be disruptive. That is, use our tools to actively and quickly react to an anomaly to prevent a certain anomaly to actually create damages in the network. So what are the requirements of these? What are the requirements that are allowing us to do this transition from the traditional traffic analysis to a security-centric traffic analysis? Well, as Luca have shown already, first of all, we need to do a deep network traffic dissection. That is, we need to leverage Ndpi, the library Ndpi, to dissect as many data as possible from the traffic, and especially from the encrypted traffic, because the encrypted traffic is more and more used every day. Now, the vast majority of the traffic is encrypted. So on the one hand, we do the deep network traffic dissection, and on the other end, we have the intelligence to correlate raw data and to identify threats. That is, use the network data along with data coming from other sources, such as, I would say, SNMP or intrusion detection systems such as SCADA, put everything together and to create insights and actionable alerts. Insights and actionable alerts that should be, and that actually are exported towards downstream collectors in standard format. So if we try to look at the ntopng ecosystem now, we can look at this picture, I would say. So we have ntopng as the central entity that contains the intelligence, and ntopng reads data from packets, correlates data with SNMP, intrusion detection systems such as SCADA, syslog, and so on. And it creates insights and alerts that are exported into standard format toward downstream collectors that can be Elasticsearch or simple email, Discord, Slack, or many other downstream receivers. So the idea, again, is to have ntopng with a central intelligence that receives data from multiple sources, including the traffic. It correlates, creates alarm, and sends alarms to the downstream collectors. This is basically the overview of ntopng, of the latest ntopng architecture. So, but let's just look at in more details at some of the features that I've mentioned. First of all, I would like to just give you an idea of what does it mean to analyze the encrypted traffic. This is the data, the result of the analysis of an encrypted traffic flow analyzed by ntopng. So as you can see from these screenshots, we are able to dissect using Ndpi all the details of the encrypted communication. We are also able to tell if the encryption is weak or not. And in this case, we are monitoring a weak encrypted communication. We also do fingerprinting. Fingerprinting is a technique to statistically decide if a certain communication is legitimate or malicious. We also look at the application layer protocol negotiation, which is another way to somehow guess the content of an encrypted communication. So we are able to put all this information together to actually generate alarms to tell you if an encrypted traffic communication is secure or not, is vulnerable or it's safe. Among the other analyses, I would also like to spend a few words on the periodic traffic analysis, what Luca have called beaconing before during his introduction, because why it's interesting to look at the beaconing, because, you know, traditionally, traffic analysis have always looked at the so-called elephant, because you want to look at the top senders, the top receivers, the top talkers, top everything. Yes, this is important to do certain kind of analysis, but the small traffic is relevant as well. It's relevant especially from a perspective of security. So in this release of ntopng, we focused on looking at the mice of the traffic, so very low traffic bandwidth flows that have a periodic behavior. That is, they perform certain actions at regular interval of times. This is useful, for example, from a security perspective, because malware is known to behave like this, that is, to perform certain actions at regular interval of times. But this is also relevant, for example, for legitimate services such as backup systems or infrastructures and application monitoring. So in the latest ntopng, we are able to detect this kind of low bandwidth periodic connection. This means that you let the software run for a while, for a few hours. The software will learn these periodic communications and will give you a simple list of all the communications, that have been learned, along with the client servers and the application protocol used. So this basically creates a taxonomy of periodic activities that you can use to decide if the activities are legitimate or if there are suspicious activities. For example, just if you find an unknown protocol which is performing periodic applications that it's worth to be inspected more to understand the nature of this periodic communication. There's also a service map, which is pretty useful, again, to understand the services, to perform, I would say, a behavioral analysis of the hosts in your network. A service map, which leads similarly to what we have seen for the periodic traffic. The service map gives you a list of all the services that are active in your network. So every client and server and the port used. Along with this information, you have also the application protocol used, and so this basically allows you to know and to detect all the services that are active in your network. So we are going to use these in the future to actually enforce policies. So basically to prevent certain services from being run. So this is basically the innovations that we have introduced when it comes to the behavioral traffic analysis for encrypted and plain text traffic. It's interesting also to have a look at the industrial and IoT SCADA monitoring that we have introduced in ntopng 4.2. But I just want to mention this now, and then we have Martin that is going to talk later in this presentation, so I don't want to really anticipate or spoil his presentation. So just let me tell you that ntopng supports industrial IoT and SCADA monitoring, and just wait here, just wait for Martin's presentation to have this part discussed in more detail. At least I've mentioned also that I and Luke have mentioned also that we are trying to turn our tool into not only into passive tools, but also in tools that can somehow react to the issues and to protect and prevent certain issues to be disruptive. And so now I would like to show you an example of this behavior. In this particular example, we use ntopng in combination with SNMP to actually disconnect a malicious host from the network. So how can we do this activity? Well, basically in ntopng we have introduced an indication of compromise, which is basically a number. This number that is such, the higher this number, the higher the chance for a particular host to be compromised. So we have this number associated to every host in ntopng. So we start monitoring all the hosts in ntopng from a security perspective. We start increasing this score for hosts that are showing suspicious behavior security-wise. And then when this score exceeds a certain threshold, using SNMP, we are able to turn the physical port of a switch or of a router down. So when a malicious host we know using SNMP the actual location of a physical host. So we really know where the host is connected in the network. So we are able to switch that particular port off. And so this is a pretty comprehensive example of the directions that we are taking with the latest ntopng. We have the traffic analysis, we have SNMP, we combine the data from the traffic analysis with the data from SNMP, we combine them together, and this combination of data on the one hand allows us to know the exact location of an host in the network. And on the other end, it allows us to communicate with the SNMP device and to actually switch that particular port off to disconnect the host from the network. So this is one of the first examples of ntopng, which is becoming something not only passive, but also it's becoming proactive, able to react to the malicious activities in the network. And finally, it's interesting also, but my colleague is going to tell you more about this later in this presentation. Another interesting thing that we have introduced in ntopng is the ability to send alerts to downstream recipient in a selective way. That is, you can define severity-based criteria or type-based criteria to decide to whom send a particular alert. This means that you can decide to only send security-related alerts to the security team and network-related alert to the network team. And you can do this in a very, very fine-grained way. And my colleague is going to show you more on this in the next presentation. And finally, among the other features and improvements that I would like to mention, Luca has already told you the part of the performance, but yes, we have rewritten many of the internals ntopng components to improve the overall ntopng performance and reduce the system load, and so process more data basically. And this is fundamental because networks are becoming larger and larger, and we always need to process more data basically. And in terms of the SNMP, we now support also the SNMP version 3. And SNMP is much more scalable. It's faster than if compared to the version 4. And we are also pretty open now. There's a pretty rich REST API that has been used and is being used by our friends and partners, and such as CheckMK. So ntopng is open. Also, if you're planning to use it in your environment, just keep in mind that you can rely also on a pretty rich REST API to extract the data or to configure ntopng to do certain activities. Yeah, that's pretty much all for this presentation. Again, ntopng 4.2 is part of our journey to move from a pure network to a network plus security traffic analysis. And we have extended it with behavioral analysis and flexible alert, basically, and we also worked on the improvement of its performance. Well, that's pretty much all. Thanks for listening, and I would just let this the next presenter. So yes, please, Luca.
Yeah. Thank you, Simone. Matteo has just joined ntop. He graduated in computer science a couple of months ago, and he's going to present you the alerting subsystem of the new ntopng 4.2. Matteo, please take over the screen.
Thanks, Luca. All right, can you see the presentation?
Not yet. No, you need to. Oh, something is happening now.
Yes.
Okay, very good.
All right. Thanks, and just like Simone previously introduced, now I talk about the new feature of the latest release of ntopng with the alerting subsystem endpoints and recipients. Now, first of all, what is an endpoint? An endpoint is a system to which you send a notification whenever an alert occurs. So, a single alert obviously can be sent to multiple endpoints, and practically speaking, whenever an alert occurs, ntopng export the data relative to the alert and send them to the specific endpoint. Now, why should you need to use an endpoint? The reason is simple, because maybe you want to receive specific alert, specific network alert on a group on Telegram, or maybe you want to get this information and send them to external services like on Kibana or Security Onion and so on, using the Elasticsearch endpoint. So today there are a total of 8 available endpoints. We have Discord, email, shell script, Slack, syslog, Telegram, and webhook endpoint. And last of all, we have Elasticsearch endpoint available in the enterprise version only. Now, how do you configure an endpoint? An endpoint can be easily configured just going into the system interface, into notifications and endpoints, and click on the plus on the right upper part of the screen. And now select the endpoint you want to configure. Here in this picture, for example, we have the Discord endpoint. Name the endpoint and follow the instructions below. For example, here for the Discord endpoint, you just need to add the specific webhook URL where you will send the notifications. Now you need to go into the notifications and recipients. Here, like before, you need to press on the plus on the right upper part of the screen, select the endpoint you previously created, name it, and you need to add the extra informations, extra options, like before, following the instructions. Now, here you can select the minimum severity of the alerts needed to send to the specific endpoint and the category of the specific alert. For example, internal alerts or network alerts. Now, for a single endpoint, you can create multiple recipients. Why you should do that? The reason is simple, because maybe you want to send internal alert to a specific group on Telegram or on Discord, and maybe you want to send other specific alarms like security alarms on another group or chat on Discord or on Telegram, and you can do that using this feature. Now you need to map the recipient to the pool, so you need to go into the pools and pools interface and add to the specific pools the new recipient created. Now, this feature has a lot of use cases. We can use it, for example, just to save this information, this alert information, into a syslog and send them, for example, to external services. Or maybe you want to send this alert information to cloud platform using webhook, or maybe you want to block attackers using shell script communicating with maybe fail to ban or firewall system, and you can do that thanks to the endpoint and recipient feature. So, in conclusion, endpoints are useful and really easy to configure tools specialized in receiving alerts in a flexible way and performing specific actions based on the triggered alert. They can be used, for example, to integrate ntopng with external system, like I said before, with fail2ban with the firewall and so on. Or they can be used to to deliver this alert to external platform using, for example, Elasticsearch and communicating it and connecting it with Security Onion or Kibana and so on. So if you want to know more about this new feature, just attend the ntopng conference part 2 on December 3rd. Thanks, Luca.
Thank you,
Matteo.
Matteo. Thank you for the presentation. The next speaker is Martin Scheu from Switch. Like I've said before, he's introducing us to the world of SCADA. He's an expert. Please, Martin.
Yes, hello together, and thanks, Luca, for the opportunity to talk about the journey in our network monitoring. Yeah, half a year ago, I think.
Martin, we don't hear you anymore. There's a problem with your microphone.
Oh, sorry. No,
no, it's okay.
No, it's okay.
Yeah, yes,
sorry.
thank you.
Maybe pressed the wrong button. Yeah, like I said, it was kind of a journey we went through because my motivation was kind of similar like Luca. I was thinking like, why is it complicated to monitor networks, and especially SCADA or industrial control system networks, or for other people, OT is like operation technology also sometimes used. So I'm from the industrial side. I didn't know network monitoring particularly, but it was a very interesting journey, and I want to give like a short presentation about that. So first is maybe important to understand what is a bit different in the industrial world. The history or evolution, it started some years back with relay control. It went over to when the first microprocessors came up. They were integrated, and then as very soon as first servers were available, they were also put in place in industrial systems, already with network and everything. But those systems were like isolated, so the network was not particular in interest of the engineers. But nowadays, with the extended connectivity, the network also in the industrial world gets very important. I have external connections, I have remote service, remote support, all these type of things, and I need to take care of that. Another important part is that in the industrial world, if you look on the right side of the picture, I do so far not care that much about how my data is transmitted over the wire, as long as it is transmitted and it get like from an outstation to the central station, or yeah, however you want to call it. Another important point is safety. This is mostly because there are legal regulations in most countries where you say, okay, the machine need to stop if that and that happens. So the focus is a bit different, but as nowadays safety also goes over the network once more, or another point why the network monitoring is important. Like I put a bit here together. Yeah, also another point, then who is running the network? That might be like the IT department, it might be OT department. I found that talking about the network is a good ground to start together, because sometimes these departments or worlds, they are divided just because of historical reasons. So when we look into the industrial control networks, we see that there are some levels. This is the Purdue model, which has like 0 to 4 levels. started at the lowest level, where are the motors, sensors, everything connected. They go to a first controller, a device which is processing this information which is coming from the field, and transfers it up to servers, historian, or as I said nowadays, to business, ERP, or even or to the internet. So in the lowest part is the network where is time sensitive. I have like an event, for example, something is moving and I have to stop the motor, and if I don't stop fast enough, then maybe something get damaged. So this is the time sensitive part. The more you go up, the more it gets similar, like the office network, and also similar in the protocols used. Here overview from, I think it's from May this year, from HMS. They do like every year kind of a survey what type of industrial protocols are used. This depends which industry you're working in, or even depends the region. It depends the supplier for control system you're using. So but it still gives a good overview, and I like it to have kind of impression that Ethernet-based protocols are like with 64% the major protocols used in the industrial world. Field bus is still like for long distance maybe, but they are mostly like two-wire protocols which are not Ethernet based. But Ethernet-based protocols you can also divide in kind of two sections. Let's say you have the time-sensitive protocols, which normally do not include the IP, TCP, UDP stack. Some they use Ethernet as well, but some they even have proprietary implemented protocols. Of course, the ones with TCP IP, they are like with ntop, for example, you can get the flows, you can see who is talking to whom, and of course you can get the payload of the packets. Just for the documentation, the safety part there normally is not something additional or an additional protocol. It's mostly implemented in a already available protocol called as black channel. So in the payload, just the safety part is also implemented. So all these protocols, they are clear text. You can see in a Wireshark what is running in each protocol, and yeah, there's no security, cyber security, like encryption, if you want to say. The difficulty maybe is that there are many different protocols. And as Simone already said, we took the IEC 104 protocol. It's a very old protocol. It was running before over 2-wire as well. And it's mainly used in the industrial distribution, but can also be like wastewater, water treatment, this type of systems. So when you look at this flow, you see that the data exchange, they are like long single flows, can run over days. So there's just one flow you see in ntop, and of course, if you just look at that, it doesn't give you that much information. And then you have a lot of flows, but it turn out it's just to like keep alive communication, because in the industrial world, as availability is important, you have mostly networks are redundant, switches are redundant, and some devices are redundant. So you have a lot of keep alive communication in very short flows. So when we started to look at the IEC protocol in the payload, it has like defined, like the protocol of course is defined with a start byte, and then like as you can see, don't want to go much deeper in it. So you have this payload in TCP packets. But then it can be that, like what we saw before, these APDUs, you can have many APDUs in one TCP packet. This is just like kind of random. We couldn't figure out with the device suppliers how that is working, but sometimes you have multiple kind of payloads in one TCP payload. So this means for the network monitoring, we need to pass through the protocol so that we not miss some information. Now, when we started, also I think Luca mentioned a bit, if you want to start monitoring the tool or like actually the starting ntop and see what is on the network, is just like, I would say it's a little part. The main part, like when we go to SMEs and say, okay, you want to monitor your network, then you need, of course, you need a commitment from the management, and you need to have like some colleagues involved. As alone, you cannot do it. And then the important thing is kind of what you want to see. You need to start with a use case, like something you want to see, and then also define what you will do when you see it. Because what comes up a lot then is kind of you find out the configuration problems. You see that some devices is broadcasting and that you don't know why. So you need to have time later on to fix these type of things in order to get your network, let's say, clear. So this is what we have done. For the IEC 104, we defined like 3 or 4 use cases, and we started with that. And by step, we added different or new use cases, and also, of course, we defined what we will do when we see that. I have a short overview, like on the traffic, like on the use cases, what we did, and some you see, like for example, the rogue DHCP DNS server. This is something we implemented on the way together with Luca and the ntop team. So that is like in the industrial network, you don't like when additional DHCP server is coming up. It can cause a lot of troubles. So this is something very nicely we done with like a plugin, started small and now is in the productive system. Running and securing the network of some small companies. Then if you go a bit more down, these are like protocol specific use cases where I even would say some actually the control system should do, like for example, value outside of defined ranges. This you should do in the control system. Of course, there are like very special applications or high demanding in safety applications, which this is not the case. But if you think about the water treatment in your town or the energy distribution in your town, that typically is a simple control system, and also people running the system, they are not specialized in cybersecurity, they are not specialized in network monitoring. These are normally electricians running just the whole site. So we wanted with this like monitoring the approaches to give them something which is alarming them but not alarming too much, and not, how to say, like overwhelming them with something then they anyway don't understand. But when you have implemented some use cases, then of course you need kind of a playbook, we call it, like to show these operators, okay, so now you got the alarm that the PLC resetted, for example, and then we tell you step by step what you need to do. In order to do that, you need first to understand what is running on your network, like the baselining, or how does normal look like, because only if you know what is okay, and then you can see in the deviation what is not good. So that is also something like Simone, I think, already said, the service map or the periodicity map is something very useful for that, where you can see how things are on the network, who is talking to whom, which protocol is used. So you can protocol that, you can discuss with the engineer to say, hey, is that okay if a machine is talking to machine B? And that helps you to get the baselining done. Then detector mechanism, that is also interesting, this risk-based approach with ntop, because there I also can, for the IEC 104 protocol, I can add this risk factor, and say, okay, if something in the protocol is not as it should be, I add this risk factor, and then if I get over a threshold, then I give an alarm. And of course, there are other open source monitoring tools or software available. We started just looking at the market, if you can say so, and see what is available. And again, with having in the mind something which is easy to install, something which doesn't need 60 gigabit of RAM or like complicated installation. And we ended up with ntop, and that helped us a lot to bring like visibility in these networks. So, and of course, very interesting to work with Luca is we can expand actually the ntop in terms of cyber security. Like we can add some new features, and with the script language is also easy. You can try something yourself, and then later on it might go into the ntop release. So with that, give it a try. If you haven't started monitoring ICS or SCADA network, you cannot do something wrong with ntop, because it's fully passive, and but it gives you a great visibility in the network. Thank you.
Thank you, Martin. Thank you for the nice words and for introducing us to SCADA. And now I let Francesco Carli talk about end-to-end. Francesco is a student of mine. I'm a professor at the University of Pisa in Italy, and Francesco will soon graduate in computer science. End-to-end is an open source VPN I started to develop almost 10 years ago, and is now maintained by the ntop community. Francesco, you can take over the screen. Hi, Francesco. We don't hear you. Please check your microphone.
Can you hear me now?
Yes, yes. Okay, feel free to share the screen.
Okay, thank you, Luca, for your invitation.
Can you increase the volume a little bit?
I think it's a max volume.
Okay, so speak loud.
Okay. So I'm going to share my screen right with you. You see the slide?
They're coming. Okay. Speak as loud as possible, please. Thank you.
Okay. So in this presentation, I'll briefly show you one of top products, end-to-end, which stand for network to network. We will see firstly which problem it solves and its architecture. And then I will introduce you the new main feature developed and implemented during all the year. So first, let's see which are the current problems related to internet and network in general, and how end-to-end solves them. While most of data interchange service are transported by internet, virtually all of them are delivered by a client-server model and are generally prevented by market-driven characteristics of internet access system. So end user do not have any control over their connection, that are totally managed by internet service providers. And moreover, there are also many issues related to network configuration and devices such as NATs and firewalls. So partial solution for the set of problems outlined so far are offered by many peer-to-peer applications that approach those problems mainly at application level. So the main focus, as you can see from these slides, is the service or the content rather than the host that provides that service. So what is end-to-end? End-to-end, as Luca said, is a layer 2 virtual private network that allows user to exploit features of peer-to-peer application, but at the network level. So it is building on peer-to-peer principle, and it's able to interconnect network resources that otherwise will not be reachable due to network configuration. For example, due to NAT and firewall, as we said before. The two main entities of end-to-end are the supernode and the edge nodes. Supernodes are used to introduce new edges in the network and relay packets to edges behind symmetrical net or firewall, as they are not directly reachable by other peers. Edges run on user host, and they are part of private or public networks. So here you can see the end-to-end architecture, both supernode and edges. Edge nodes have a list of supernodes to which they register at their startup, and they will register to the first node in that list. Then the registration to the additional supernodes, if they are present in the list, of course, happens if the supernode to which edge is registered does not answer. Supernodes temporarily store information about the edges, and those information need to be refreshed time to time. So, as you have read from previous slides, end-to-end is also able to cross NATs, thanks to the technique reported also in that slides. That is called UDP hole punching. So end-to-end provides layer 2 broadcast via the supernodes, which forward broadcast and multicast packets to all edges in the community. As edges receive remote packets, they send the registration request directly to the peers, and that way the peers registration mechanism provide a technique to form a direct connection between edges, removing the supernode from that path. If both peers of a communication are behind symmetric net, direct connectivity is not possible. Then these nodes should communicate with the help of the supernode. Talking about 2020 new feature, they are related to encryption and communication protocol. Regarding crypto feature, they have been implemented mainly by Logan 07, and they concern new optional stream ciphers and full header encryption. As concern communication protocol, we decided to switch from a semi-centralized protocol to a fully distributed one, and Logan and I, we developed all this feature with also the help of Prof. Derry and all the ntop community. That way, end-to-end is able to resist security attacks and exploit the distributed network and its characteristics. Developed features as a special community of supernodes, communication between supernodes, and a selection strategy for load balancing. So, payload encryption was performed by two ciphers so far, AES and two fish, but two new stream ciphers have been added to the code base. CHA-20 is an optional stream cipher, and the user can enable it using A4 option from command line interfaces. It's usually performed faster than software AES, but maybe not than hardware accelerate AES, especially on x86. Spec is the other new stream cipher, which can be selected using A5 option from command line 2. It is recommended by National Security Agency if AES implementation is not feasible due to system constraints or characteristics. And anyway, all these performances about ciphers can be compared running the benchmark tool, which it can be found under the tools directory. Moreover, is now available a full header encryption, which can be enabled by H option from command line interfaces. If a user enables this new feature, all metadata fields get encrypted using the new spec cipher. Be aware that payload decryption happens independent from header encryption, as it is performed using one of the 4 ciphers mentioned before. So keep in mind that they are separated mechanisms. Enabling full header encryption, any DPI tool can be evaded, as it won't be able to classify end-to-end traffic just from looking at the packet content. Regarding new distributed communication protocol, one of its features allows supernodes to communicate each other, thanks to a special community called Federation. Supernodes inside this community have the same feature that edges in regular communities have. So federated supernodes can register each other and exchange messages and data. That way, supernodes can now communicate each other and share their knowledge with edges. And edges, thanks to this communication and this information sharing, will be able to know, for example, which other supernodes are part of the network in a specific moment, and handle this information according to their specific configuration or strategies. But why this feature is so important? Why this is very important? Because, for example, if a supernode suddenly fails, the edge will be able to register with another one, thanks to that gained knowledge received from supernode. The new supernode is chosen according to a load-based selection strategy that allows to balance the entire load of the network in a fair manner. This strategy, in a nutshell, sorts the list of supernodes time to time, and the first supernode in the list after that sorting will be the one with less load, and so the most suitable supernode to accept new registration request. So why a user should use end-to-end? Because using it, he will be able to create his own private network and could invite other people to join it without network administrator intervention. Moreover, thanks to the new feature, end-to-end is safer and able to resist security attacks and manage supernode fails. Compared to other peer-to-peer technologies, its major advantages are the ability to create a private network without a central control point, a direct packet exchange, which increases network efficiency and reduces latency, and that is transparent and usable by all applications without any end-to-end awareness. So a very simple session can be started running these commands on different hosts, and after that, hosts can ping each other and perform other more complex actions, such as the copy of a file, etc. Anyway, it is strongly advised to choose a custom community name and a secret encryption key with C and key option in order to prevent other users from connecting to your computer. For the privacy of your data and to reduce the server load of supernode.ntop.org, it is also suggested to set up your own custom supernode, and you could find the steps on how to do it on the GitHub page. So this is my last slide, where you can see all the links to find end-to-end product, binaries packages, and the source code on the GitHub page. I think that's all, and I leave the floor to the next presentation. Yeah. Thank you, everybody.
Thank you, Francesco. Very nice. If you're wondering why we have started to develop end-to-end, the use case is pretty simple. In essence, we wanted to have the ability of reaching our monitoring boxes behind the firewall, or to create a simple and secure network overlay among them, so that it's possible to talk with monitoring devices even if they are remotely connected, even if they are protected by firewall devices in a secure way. Since that, many things have happened thanks to Francesco, to Logan that is here with us, and to many other people. The tool has been extended. It's able to run on very small devices and is very secure, like Francesco said. Okay, Alfredo, it is your turn.
Thank you, Luca. Can you hear me? Can you hear me?
Yes,
Can you
yes.
see my screen?
Yes.
Everything is working. Okay, thank you. So, hi everyone. I will go quickly through the new features and improvements of PF-Ring and Ntop to leave room out of time. Start from PF-Ring 7.8 that we just released. First of all, what is PF-Ring? PF-Ring is a packet capture framework. So it's a library that we use in our application to capture packets at high speed, and we support standard adapters interbased with our accelerated drivers or FPGAs. And we also provide other features like filtering, packet parsing, flow processing with PF-Ring FT. So we try to assist the application capturing packets fast and do the processing. Last year, Intel announced a new Intel adapter able to support 100 gigabit connectivity, the Intel E800 series. And it has been released a few weeks ago. This is the successor, at least from our point of view, of the FM10000 adapter, which is, let's say, more like a switch. It actually contains a switch inside that you can program, but it's not really fast. And we have seen there is, at least in the version that we have seen some bug. So we are not really happy with that. And this looks like a good replacement. This adapter supports 110, 25, 50, 100 gigabit connectivity. And it's also programmable. Actually, you cannot program it yourself, but Intel, using skills, first of all, and an SDK, can build special firmwares for adding special offloads like parsing, I don't know, GTP traffic, for instance, which is usually not available in a standard adapter. And you can improve, for instance, RSS, so receive side scaling, so the ability to spread the load across multiple data streams to parallelize the application. You can extend that functionality using this DDP to compute an hash on GTP traffic, for instance. And this low-cost adapter, it's like 700 euros, dollars, sorry. So it's a commodity adapter that you can use for 100 gigabit low cost. This new release of PF-Ring, we added the IC driver, which is the driver for this new adapter. And we run performance tests, and it looks like it's quite fast. So we are able to receive 25 million packets per second with a single thread, a single data stream. And you can use RSS to spread the load using multiple data streams, so you can scale the performance. And it seems it's scaling really well. In fact, we tested this adapter with a real application, our Mprobe Cento, and using 6 cores, we have been able to process 80 million packets per second, which is 100 gigabit if you consider average packet size, so standard internet traffic. There are other features in this PF-Ring release, like the support for Arista packet trailers and keyframes. So if you use a packet broker from Arista, you can extract from packets the device ID, the port ID, and you have the hardware timestamp nanoseconds for packets. We extended the zero copy API. It's simpler to use it now. It's already one of the main advantages of this library is already the fact that it's really simple to build complex processing patterns. But we further simplify the API. For instance, we also have now the ability to use BPF filters, not just for packets that we capture from an interface, so to filter received packets from interface, but also packets which are received or transmitted on software queues or transmitted on interface. And we also improved the FT library, which is a library that assists the application in flow processing. So you can build your probe, for instance, based on this library with lines of code. And we added some improvement to this library, including, for instance, the slicing. So the ability to deliver, to export periodic flow updates before the flow termination. And those are the main features in the latest PF3 release. Now we'll go quickly through the end-to-disk, the new features and improvements in end-to-disk. But in any way, we will see use cases and practical use and configuration examples of end-to-disk in the next webinar that we will have on December 10th. So don't worry if I will go a bit too fast here. So end-to-disk is network to disk, so is packet recording. So we record raw packets in pickup format to disk. And the new end-to-disk release, actually even the previous one, is able to record up to 100 gigabit to disk using, of course, fast storage that we will see later. And those packets are not just recorded, but they are also indexed and organized in a timeline to be able to retrieve the packets that you need in a specific time interval and matching a specific filter, so BPF filter. So these implement what we call a continuous recording, because at some point we want to go back in time and see what happened when a network issue happened to troubleshoot it, or if there is a security incident, we want to get the packets matching the incident. So in essence, end-to-disk keeps a sliding window with raw packets in the last period of time. And the size of this window is actually the data retention. And if we look at 100 gigabit, we have 12 gigabytes per second to dump to disk, which is 1 petabyte per day, which is a lot of data. So we need a huge storage to keep even 1 day of data at 100 gigabit. And then we also need to face with performance, because at 100 gigabit, standard hard disks cannot be usually used unless you have, I don't know, multiple write controllers and you load balance across write controllers, but it's usually not convenient. We usually, in our configurations, we usually use NVMe disks, which are SSD disks directly attached to the PCI. And in order to dump 100 gigabit to disk, you need at least 8 NVMe disks. The problem with those disks is that they are usually available in a limited number in a standard appliance. They require a lot of resources, because when you use NVMe disks, you don't use a write controller, but we have N2disk writing in parallel to all the NVMe disks directly in order to go fast and be able to reach the 100 gigabit throughput. N2disk allocates resources for doing that, so it requires a lot of resources. You cannot handle hundreds of NVMe disks. And they are, of course, more expensive than hard disks. They used to be even more expensive a few years now. They have reasonable prices, but still they are expensive. So we decided to go with an hybrid topology, let's say. So we use NVMe disks as a cache, as a main storage that we use just in to keep up with the traffic during busy hours, to handle peaks, let's say. And then we move the pickup files to be done on this cache to the big storage, which is hard disk based during, let's say, off peak. So when we have time or overnight. So in this new release of N2disk, we added with new archiving support in order to be able to move the pickup files from the cache to this big storage. This is more or less the architecture. So you have N2disk writing to the NVMe cache, and then those pickup files and the index are moved to the storage. And here you can have a huge storage. But sometimes this is not enough, because at 100 gigabit, as I said, you have a lot of data. Even a huge storage is not enough. So what are the other options? We can filter the traffic, of course. We can do packet slicing. So if you're not interested in the packet payload, we want to dump just the header, we save a lot of space because network packets in average, if we look at the Ethernet traffic, are more than 500 bytes. Instead, the headers itself, they're under 60 bytes. So you save a lot of space if you just dump the headers. So you can enable packet slicing into disk, or you can enable the compression, the peak of compression. But if you are dumping, it depends on the traffic. It could be it's not convenient because it adds overhead on the CPU, of course. And if you dump, for instance, internet traffic, it doesn't save a lot. It's just 5% of the traffic because it's already compressed. It's almost already compressed, like JPEG, MP3, MPEG-4. So this traffic is already compressed, or it's difficult to compress if you think to TLS traffic. Instead, if you have LAN traffic, usually you can compress it very well. Even high-frequency trading traffic, you can compress a lot, more than 50%. So you save a lot of space in this case. We support filtering up to layer 7 because it's difficult usually to filter based on the IP and port. But if you look at the traffic, for instance, internet traffic is about 70% of multimedia traffic that we usually don't care about. Instead, the portion of traffic which is interesting, which is what you see in the picture of the other or communication traffic, it's a small amount of traffic. So you can use the layer 7 filtering into disk to say discard all the, I don't know, Facebook or maybe not, but Netflix, Spotify traffic. Or you can shunt the traffic. What does it mean? Shunt means that we want to record just the first packets of each communication so that we know that there is a communication, and then discard the rest of the traffic. So we can even dump the beginning of also Netflix sessions, but then discard the rest of the traffic, which is just the movie itself, so we don't care about it. Okay, and disk is able to index the traffic and is able to index now the traffic also up to layer 7. So for each packet, it stores information about the application. So when you extract the traffic, you specify the time interval and you specify, I don't know, the IP address and also the layer 7 protocol. So you can extract the traffic from 9 to 10 this morning, matching this host and layer 7 protocol Facebook, for instance. We also improved this release the traffic replay because ntopng has a companion tool which is disk2n, which is able to replay traffic that we recorded. We used to replay this traffic at the original traffic speed, but now we also have options to replay this traffic, controlling the speed. So you can specify the number of packets per second, the bit rate, so megabit or gigabit per second, or the relative speed, so 50% of the original capture rate. And it's important because when you have to test the performance of the device, you want to send to this device traffic at a constant rate and probably higher than the rate that the original pickup. Or sometimes you want to slow down the rate because you want to debug some issue and you have to receive a few packets per second. There are other features, including, for instance, visibility. So the ability to have the visibility of the traffic using, for instance, ntopng while dumping the traffic to disk. So ntopng is able to export the metadata to ntopng while dumping raw packets, so that we can integrate the two tools. You have a single box or even two different boxes looking at the same traffic at high speed. And we will see this in the next webinar that we will have on December 10th, as I said. Okay, this is everything. I think we can go with the open discussion.
Yes, exactly.
Okay.
Thank you, Alfredo.
Thank you.
So sorry, we have been we have been planning for a shorter event, but unfortunately it was a little bit too long. So we are here to hear what in essence what are your reactions, or what you have in mind if you have questions. And to remind you that we'll have 2 more events in early December. So this is also something to important to remember, because if those who are interested in ntopng can join us at the new webinar December the 3rd. And December the 10th, there is also a new webinar where Alfredo will be talking about more extensively about N2Disk. Today was a quick presentation. Okay, if somebody has questions, we are here to listen. And in particular, if you have comments on the roadmap, or if you believe there are other priorities, let us know.
Hi, Luca. Hi, ntop team. I
Hi.
just wanted to know about SNMP mitigation. Should you program to maybe use a way to null route traffic directly instead of using SNMP?
Okay, Simone, do you want to reply? You did the presentation. Do you want me to do that?
I didn't get the question, actually.
So I wanted to know, instead of doing SNMP mitigation, maybe with IP tables, you should be able to null route the traffic directly?
Well, I think that is doable. That is doable because actually my colleagues, Luca and Matteo, have done an extension to the latest ntopng to execute shell scripts. So it would be pretty simple to create a one-line shell script actually to inject IP table rules, I guess. So, I mean, I think it's doable with
shell scripts, not with SNMP.
You mentioned injecting rules into IP tables, correct? So
correct.
Yeah, so I think that using a shell script would be the preferable way to inject rules into the IP tables, at least for a local ntopng.
Okay, good.
Thank you. Anybody has comments on our plans? Do you want to give us some feedback?
Maybe, Luca, we can talk about what we discussed on Discord about the mobile app.
Yeah,
because
okay,
we
sure.
don't have any reply too much in Discord, so maybe we should ask the community right here.
Okay, we'll go to Discord. Yes, sure. Other questions about what we presented today? Curiosities? Okay, Greg has sent us a comment. Okay, Greg is interested as a comment to be part of the next 2 meetings where we have to go deep into the tools. Yeah, the next one, like I said, is about ntopng and an edge. And the one after, Alfredo will give a better in-depth discussion of the new features of N2Disk and also of nscrub, in addition to also to pfring. Sure. Is any of you using the 4.2 version of ntopng? Do you have any problem? Do you want to give us a feedback? Well, probably the best for this type of tools is to use Discord, I believe.
The next session will be talking about best practice, right?
Yes.
Yeah, okay.
At least mine, yes.
Exactly, yeah.
Okay.
December the 3rd would be ntopng, and December the 10th would be Improbe and ntopng. If you go on our website, you will see there are 2 different links for these new meetings. Okay, it's not the same that you used today. Yeah, there are 2 different ones.
Cool.
Okay, guys. No more questions. If you want, we can stop here. We have done, a very a very long session. I would like to remind you that you can join us on the ntop community. We try to support and talk with our community around the clock. So it's important for us to stay in touch, and in case you have questions or anything, please let us know. And as last thing, I would like to remind you that for those who have been here today and are interested in buying some for commercial licenses, in addition to the open source and free one, you can use this discount code on our shop that will give you a discount on licenses. Okay, I think we are good today. If there are no more questions, I think we can wrap up here. Thank you everybody for being here. We'll share the recording, of course, and we'll update the web page where we talk about the conference. Add the new link to the recording, and of course we'll put them on the YouTube channel of ntop. Thank you very much, guys. Have a good day. Bye bye.
Thank you. Thanks to everyone.
Thank you. Bye bye, everyone.
Have a nice day.